My name is János Visaso. I'm Chief Operations Officer at Boda International Limited. We hope to contribute towards, let me say, less impact on pollution and overall climate change in Uganda and especially Kampala. One Boda at a time, one fishing boat at a time, one walking tractor at a time. So we really hope to replace a lot of the relatively inefficient petrol and diesel power plants that are traditionally used in light mobility applications. So that is our immediate focus in the next 2 years. And beyond that, we hope to be able to transition into medium and larger mobility applications as well. A typical petrol motorcycle will produce about 2.5 to 3 tons of carbon dioxide per annum, which is quite a significant amount. That is based on both petrol and oil that is burnt typically. So one e-Boda, one electric Boda, is essentially 100% effective replacement and therefore offsets 2.5 to 3 tons of CO2 per annum. That is a very measurable size, but we still see it as the beginning. One of the next products that we look to avail to our regional market is an electric outboard, where the emissions of the two-stroke outboard engines are typically 3 to 4 times as much as in the two-wheeler use case. In order to enable us to replace these mobile applications, we have developed a smart battery. The smart battery consists of lithium-ion based cells, and we have furthermore developed one battery management system, a proprietary battery management system, as well as a charger that are all packaged within the same battery pack. So this package that we have developed allows us to take in AC from the socket to democratize charging. It will offer a rider typically about 60 to 70 kilometers range on a single battery. Next year that should be ramped up to about 100 kilometers for a typical rider. And beyond that, we hope that we can introduce a standard in terms of batteries such that we can once again also reduce the impact of waste, because we do believe that e-mobility will be coming into the East African region. And if we wait for others to deploy their battery standards locally, then we'll be stuck with their waste. If, however, we engineer our own batteries locally and we have the ability to add value and lifetimes to them, then we stand a chance to have a really sustainable ecosystem where most of the value addition, because the battery is the most capital intensive component of electric mobility, is locally manufactured and assembled as far as that is possible. These are all recycled cells. These cells are essentially won from old laptop battery packs. This is what we were able to start our business with in 2018. We did not have the ability to import new LG Chem based cells, which we're using in our mobile applications. So new cells for the first life application, used cells for the third life application. We validated our business model before basically we were able to take delivery of our new cells. So behind me you will see part of the testing setup that goes into gauging at which capacity the cells are remaining. My colleague Michael is responsible for taking these batteries and sorting them into their groups according to capacity, cell type that is captured in our database. And finally, when we have accumulated enough cells of a certain type and a certain capacity, we can re-engineer an application or upcycle an application such as a power bank. So I have an example of that. This is the recycled resource, and this is the brand new resource. That's the difference. So these cells are equipped with the 2,900 milliamp hours of storage capacity at 3.7 volts nominal. The cells that we typically recycle from laptops will have been delivered with about 2,000 to 2,500 milliamp hours at 3.7 volts, meaning that their capacity is initially not only lower, but having been pre-used in the lifetime as a laptop battery, we're likely to have about 1,500 to 1,800 milliamp hours remaining, and that is what we can use in our third life applications. So that's about half of the capacity. You're likely to find half of the capacity and discharging rate in this cell than you are in this cell here. It is also vastly more expensive, this cell here. So, what is happening here is that my colleagues Sharon and Amon are overhauling one of the electric vehicles that we had actually first converted. By this time we were still using hub drive, so a motor within the rear wheel. This has a slot for 2 of our Boda batteries according to our 2010 standard. This is the output of the battery, and ultimately this is the intake. So this is one of the very first bikes we built, which is back for an overhaul 2 years later. And if I can take you back forward, I can take you through the transitions that we are expecting in the next 3 months. So this is where we are coming from. So this is one Boda battery according to how we have been producing them in 2020, powering an automatic drivetrain with a mid-drive and a sprocket drive at the rear. Where we are headed in terms of the commuter version, we are staying automatic. We are adjusting our battery standard, we are adjusting our connector standard, and ultimately we look to be able to squeeze about 50% more capacity out of this new case as we transition from 18650 lithium ion cells to 21700 lithium ion cells. So yeah, those will be the next developments in our product life cycle.
Transitioning from,
but we can contrast them so that you get an idea. So this is basically old and new. So this is the outgoing 2.2 kilowatt hour battery, taking a rider typically about 60 to 70 kilometers on a charge. And this is the 3.3 kilowatt replacement that is being developed for next year. This new battery pack will contain the proprietary battery management system and charger I mentioned earlier, and will allow us to charge the battery directly off AC, DC, without a further charge controller, without an extra charger. Basically, it's an AC-DC enabled battery, and any regular 230 volt wall socket or 2S configuration in a solar panel can be used to charge this battery directly.
how many kilometers?
This one should average out at about 100 to 110 kilometers for the rider. Yes.
This one is 60.
Yeah. So this one typically would be something like 60 to 70 kilometers. Yeah. This is 100 to 110 kilometers. Yes.
Wamala Jackson gemanya gange. Piki zino ezitakozesa mafuta nungi nnyo okusingira ddala piki eri ey'amafuta, kubanga piki eno etakozesa mafuta, tekozesa oyiro, teyina lujegere, kwegamba tefuuwa mukka, ebyo byonna ebitawaanya ku piki erimu nti sima yakula kiziweddeko, ebyo byonna obeera togenda kufuna complaining yabyo. So obulungi bwayo eno nga bwoga nti eri ogenda mu service kugikola service eno okujjako nga breeki ziweddeko,